In this example, we want to solve the exponential equation. And it says express irrational solutions in exact form and as the decimal rounded to 3 places. So before we start on this example, I just thought we'd take a minute to look at the different methods that we have for solving exponential equations. The first one is relating the bases, or it's sometimes called the one-to-one property. You can use this method whenever you can write your equation with the same base on both sides of the equation. In our example, we have a base of 6 and a base of 5. We're not able to write those two sides of the equation with the same base, so we're not going to be using the relating the bases method for this example. Then the other two methods are convert the exponential equation to a logarithmic equation. So that's when you are going to rewrite your exponential expression as a log expression. Excuse me, I should have said equation. Your exponential equation as a log equation. And we can do that with this example. And then the other method is to take the log of both sides. So if you have your exponential equation, you can take the log of both sides. I like to use natural log. Once you take the natural log of both sides, that introduces your properties of logarithms. And one of the properties that we can use here is the power rule to take this variable out of the exponent. And then once it's out of the exponent, we can get that variable by itself by dividing both sides by natural log of b. And we're able to solve for that value of x. So I'll show you the converting to an exponential equation method, and then I'll go through the taking the log of both sides method. So first I'll show you solving this equation by converting. So to convert this to a log equation, I'm going to write the word log, and I'm going to use the base of the exponent as the base of the log. Now this is a unique example in that we have two bases. You have a base of 6 and a base of 5. You can choose which of those you'd like to use. So I'll use the base of 5. So we have a base of 5. The log always equals the exponent. That's going to be x. And then what's inside the log is the other side of the equation, which is the 6 to the 1 minus 7x. Now from here, we have quite a bit of solving to do still. We're going to use the power rule to bring this power out of the exponent. We need to do that because that exponent has a variable in it. So that would be 1 minus 7x times log base 5 of 6 equals x. Then I'm going to use the distributive property. And I'm distributing this log base 5 of 6 to both of these terms. So that would be log base 5 of 6 minus 7x log base 5 of 6 equals x. Now I have two terms with x in it in this equation. I want to move all the terms with x to the same side of the equation. So I'm going to add this 7x log base 5 of 6 to both sides so that I can get those variables on the same side. That's going to cancel out on the left, leaving me with log base 5 of 6 equals x plus 7x log base 5 of 6. From there, I'm going to factor out the x. When I factor out the x, I'm left with 1 plus 7 log base 5 of 6. And now I can get that x by itself by dividing by what's in the parentheses, 1 plus 7 log base 5 of 6. I'm going to do the same thing onto the other side. That cancels out what's next to x, and now I'm left with my solution. X equals log base 5 of 6 over 1 plus 7 log base 5 of 6. Let me get my calculator and we'll type that in to get the decimal approximation. What I have here is the exact value. So I'll type that in my calculator. I need to go into the Math menu. The bottom of the list has a log base function where I can specify base 5 of 6. That's my numerator, and in the denominator, because I have multiple terms, I need to put parentheses, 1 plus 7 log, once again I need to get that special log from the Math menu, because that allows me to specify the base, log base 5 of 6, and closing parenthesis for the log and closing parenthesis for the denominator, and we get our decimal approximation. And I believe it said 3 decimal places. That's 0.127 if we round it to that third decimal place. Now, some of you may not have a calculator that allows you to put the specific base in. Some of you may only have the buttons on the home screen, log, which is base 10, and natural log, which is base E. So if that's the case, then you would need to convert your log base 5 to one of those bases so that you could type it in the calculator. So I'll convert this to natural log, and this is what it would look like. Natural log of 6 over natural log 5, that's for the log in the numerator, and 1 plus 7 times natural log 6 over natural log 5. So this is what I would need to type in, and I'm putting parentheses in all the places I'll put it in when I type in the calculator. So in the numerator, I have natural log 6 divided by natural log 5, and that's my whole numerator. Then I'm going to divide, open parentheses for the denominator, and I have 1 plus 7, do parentheses, natural log 6, close parentheses, divided by natural log 5, close parentheses. Now I'm closing parentheses for the log part, closing parentheses for the denominator part, and hit enter, and you can see we get the same approximation, 1.27. Now I'll work that same example with the method of taking the log of both sides. So I'll take the natural log on the left and the natural log on the right. This is something we're allowed to do because log functions are one-to-one. So taking the log of both sides gives you an equivalent equation. And once we introduce the logs, we now can use the properties of logs, and the one we're going to use is the power rule. And we're using the power rule because that allows us to take the expression in the power out of the exponent. We want that variable out of the exponent so we can solve for it. So with the power rule, we get 1 minus 7x natural log 6, x natural log 5. I'll use the distributive property on this part to distribute the natural log of 6 to each term. That would give me natural log 6 minus 7x natural log 6 equals x natural log 5. And now I notice I've got variables in multiple terms. I want to move those terms with the variables to the same side. So I'm adding 7x natural log 6 onto both sides of the equation. It'll cancel out on the left side, leaving the left side only with natural log 6. On the right side, we have x natural log 5 plus 7x natural log 6. Then I'll factor out the x that these two terms have in common, leaving me with natural log 5 plus 7 natural log 6. The other side I'm just carrying down. And now I can get the x by itself on one side by dividing both sides by what's in the parenthesis. Doing the same thing on the left. That'll cancel out on the right, and I'll have my solution. X equals natural log 6 over natural log 5 plus 7 natural log 6. So this is the exact value. And I'll use the calculator to get that decimal approximation. So I can use the natural log button on the home screen of my calculator. Natural log 6 divided by, I need parentheses around the whole denominator. So that's natural log 5 plus 7 natural log 6. And I'll close parentheses for the denominator. And you can see we got the same value from before, 0.127. Thank you for checking out my videos. Have a great day.